Okay, so we're going to have a little look at how we would approach maths problems in science. And I've given us an example here of something that you'd find early on in the physics part of the GCSE, AP1. And I would always remind people of this particular method, where the first thing we do is fill in a grid. Right, and the grid is designed essentially just to pull information out of the question. You know, we've not got a particularly wordy example here, but in the exams, there is a greater level of kind of written literacy skills, and unpicking what the question's asking me to do is actually a large aspect of the question itself. So 6 kilojoules of energy are required to melt 3 kilograms of a substance at its melting point. What is the specific latent heat of fusion of the substance in joules per kilogram? So as I'm reading through now, I would start to fill in some of this information. The 6 kilojoules of energy. So I've got energy, and I want to be asking myself every time, what unit am I supposed to be using for energy? And for energy, I'm just supposed to be using joules. Now in the question, it's not given in joules, it's given in kilojoules. And by doing this, I'm reminding myself that I need to actually change this from kilojoules into joules. And whenever I see kilo, that means I need to times it by 1,000. Right, in the same way that there are 1,000 meters in a kilometer, a kilometer, there are 1,000 joules in a kilojoule. So my energy is in 6,000 when it's being measured in joules. Let's keep reading. So 6 kilojoules of energy are required to melt 3 kilograms of a substance at its melting point. Now this is quite a usual thing to happen. They don't specifically tell me which quantity 3 kilograms is representing. They're expecting me to realize that that is talking about the mass of substance. All right, they're expecting me to identify that if something is measured in kilograms, and kilograms is the correct unit to use here, if something's measured in kilograms, it's telling me about the mass of that object. And it's telling me that the mass in kilograms is 3. And it says, what is the specific latent heat of fusion of the substance? That's what I'm being asked to calculate. What is so that's the last thing is what I'm being asked to calculate, and it's asking me to calculate the specific latent heat of fusion in joules per kilogram. Okay, we could have equally done this in terms of symbols instead. So we could have written a symbol E for energy. We could have written a symbol M for mass. We could have written a symbol L for the specific latent heat. Right, what I often do is if it's the specific latent heat of fusion specifically, I'll put a little subscript F down the bottom there to let me know it's fusion, specific latent heat of fusion I'm looking for, rather than the specific latent heat of vaporization. When we then go to complete this question, the next step I would expect pupils to carry out is to write down the equation. Right now, if you're struggling to remember what equations are at the moment in your diary, there should be an equation sheet, I think page 52 or thereabouts, depending on what year group you're in. And you would look for the equation that links energy, mass, and specific latent heat of fusion. All right, we've got our grid down now. We already know that those are the 3 things that we're concerned about in this question. There will only be one equation on there that links exactly those 3 things. And you'll find that it is energy, or we can write it in terms of the symbols, equals mass times specific latent heat of fusion. Okay, we've written it down in terms of symbols. Remember, just like in your maths lessons, if you have 2 symbols next to each other, it means they're being multiplied together. No need to put the multiplication sign in there. We don't want to think that there's a new symbol X. And now I would advise people to always put a dotted line through the equal signs. Keeps everything nice and neat rather than scattering all of your working out across the page. The examiner's going to have a really tough time trying to find out and piece together exactly what your thought process was. Now we can start to set some numbers in. So energy, well, I do know what that was. That was 6,000. What else did I know? I knew that the mass was 3. I didn't know, or I certainly don't know yet what the latent heat of fusion is. So that can just stay like this. right? Just as a brief point here as well, this hopefully is going to show us why it's important that if I do want to include a second letter in a symbol, for example, an F to show its latent heat of fusion, that I draw it as a little subscript. Okay, if I had drawn it as a large letter, if I drawn, for example, M, L, F, that looks like there are three things being multiplied together. Okay, that's incorrect. That's not what we're looking for. Right, please do not write two big letters as part of one symbol. It looks like they are two separate things being multiplied together. So that's incorrect. We wouldn't like that. We've drawn it as that little subscript F. What do we need to do now? Well, we're trying to find latent heat of fusion. Remember, we've got that question mark there. That's the goal of this question. You need to ask yourself, what do I need to do to both sides of that equation to get L to be on its own? Okay, well, it's currently being multiplied by 3. To undo that multiplication, we need to divide it by 3. If I divide one side by 3, I have to divide the other side by 3. Right, whatever I do to one side, I do to the other side as well. Okay, and hopefully we should be able to see that 6,000 divided by 3 is, slight miscalculation, is 2,000. And at 2,000 is equal to, well, on my other side, that 3 is just going to cancel out on the bottom, isn't it? So it's just equal to LF. Now, something, doesn't quite sit right with me if I write it that way round. We're reading from left to right. I would just put then LF equals 2,000. And don't forget your unit. We've got a unit in here, joules per kilogram. There is my final answer.